Humphreys, University of Massachusetts, Lowell. Actually did his research in conjunction with the Natick Laboratories outside of Boston, manipulating electrospun nanofiber formation from polyethylene oxide by surfactant addition.
I conducted this research as a part of a 3-month co-op at the U.S. Army Natick Soldier Research Development and Engineering Center the summer after my freshman year at UMass Lowell. So my research was on manipulating electrospun nanofiber formation from polyethylene oxide by surfactant addition. Electrospinning is the process of using polymer solutions and applying large electric potential to create non-woven nanofibers. And these fibers are of interest by the military because they are potentially can be used for applications such as smart clothing, protected fabrics, microelectronics, as well as drug delivery devices and more.
Our second speaker is Blaise Javier Mandela of FIT in New York, Fashion Institute. Our paper is Transparency, the Unlikely Steward of Increased Profits Through Corporate Accountability and Social Compliance in Global Textile and Apparel Sourcing. Blaise.
So for an introduction, corporate and government scandals from recent memory have disrupted the trust between the American public and the private sectors. So my methodology, it's a qualitative project. It combines original and secondary research with analysis of primary documents and real-life Invenia cases. Research sources include government and industry documents, professional journal articles, interviews, and normative costing strategies in the apparel industry. Reference events include real-life scenarios such as the Rana Plaza collapse, the Uzbekistan cotton conflict, and this research strategy is used to explore the implications of ethicality on transparency, considering the aforementioned concerns.
Our third and final paper to present this afternoon is by Purva Banerjee from our sister institution in Georgia, the University of Georgia. We like to play very often on the football field. We do have a lot of technical interactions with them. Title of the talk is Study of Biocompatibility and Cell Proliferation on microalkyl polyhydroxybutyrate PHB fiber structures for wound healing applications.
Thank you, Dr. Cook. Good afternoon, everybody. Today I will be talking to you about a biodegradable polymer called PHB, or polyhydroxybutyrate, and its applications in wound healing or the biomedical field. To begin my presentation, I wanted to set the premise. Let's talk about synthetic plastics or petrochemical plastics. There are numerous applications in the textile industry, such as they are used in fibers, polymers, detergents, intermediates, performance plastics, and many such applications. But according to one of the reports written by the plastics manufacturers in Europe in 2013, in 2010 alone, the annual production of plastic was 300 million metric tons, and about half of that was disposable plastics. And when we look at all the ways you can discard plastics, the highest way of discarding plastic was landfill. It was 38%. How do we combat this? We look at biopolymers. Yes, that's the future of the plastic industry. The various viable candidates in the biopolymer arena are polynucleotides, polyamides, polysaccharides, polyoxoesters, and one such polymer belonging to the polyoxoester family is polyhydroxyalkanoids. They're microbead
likely steward of increased profits through corporate accountability and social compliance in global textile and apparel sourcing. Okay. Thank you. Second place winner is Purva Banerjee from University of Georgia, and I really hate that a tech professor has to be awarding money to the University of Georgia, but that's the way it turned out. was titled The Study of Biocompatibility and Cell Proliferation of Microalgal Polyhydroxybutyrate Fiber Structures for Wound Healing Applications. Congratulations.
Thank you.
So that leaves our first and final recipient, and the first place winner is Michael Humphreys of University of Massachusetts Lowell. Michael. Michael's title was Manipulating Electrospun Nanofiber Formation from Polyethylene Oxide by Surfactant Addition. So Michael, you get the big one.